The way engine cylinders are arranged is called the engine configuration. Inline engines have the cylinders in a line. This design creates a simple-to-cast engine block. In vehicle applications, the number of cylinders is normally from 2 up to 6. Usually the cylinders are vertical, but some manufacturers lean them to one side. Engines tilted in this way are called slant engines. Tilting an engine reduces its height. This can reduce the height of the bonnet as well, which allows a more streamlined body shape. Tilting can be carried to an extreme by lying the engine completely on its side. It is then called a flat engine. This greatly reduces engine height. As the number of cylinders increases, the length of the block and the crankshaft can become a problem. One way to avoid this is with a V configuration. This design makes the engine block and the crankshaft shorter and more rigid. In vehicle applications, the number of cylinders can vary, usually from 4 up to 12. Common angles between the banks of cylinders are 90 degrees and 60 degrees. V-type engines are wider than inline engines and may also be lower. Horizontally opposed engines have 2 banks of cylinders, 180 degrees apart on opposite sides of the crankshaft. A useful design when little vertical space is available. It's shorter than a comparable inline engine, but wider than a V-type. A rotary engine uses a rotor in a housing instead of a piston in a cylinder. This provides a very compact power unit. This section examines a basic carbureted system. A basic carburetor system consists of the fuel tank to store the fuel, fuel lines or pipes to carry fuel in the system, a pump to transfer fuel from the tank to the engine, a filter to clean the fuel, an air cleaner to supply clean air, a carburetor to atomize the fuel and provide the correct mixture of air and fuel, the engine intake manifold to deliver the air-fuel mixture to the engine. This section examines basic EFI systems. EFI systems use electronically controlled injectors to spray the fuel. There are 2 basic systems: throttle body injection, also called single-point injection, and multi-point injection. Throttle body injection sprays fuel into the air as it passes through to the intake manifold. Multi-point injection has an injector for each cylinder, which sprays fuel directly into the intake valve port. The whole system has a fuel tank to store the fuel, a fuel pump to circulate fuel and provide pressure in the system, a fuel filter to clean the fuel and protect the injectors, a fuel rail or pipe to supply the injectors with fuel, injectors which spray into the intake valve ports, a pressure regulator to control pressure in the system, a throttle body with a throttle valve to control the flow of air to the engine, an air cleaner, ducting and an airflow meter to provide clean measured air, and a plenum chamber or surge chamber to dampen the flow of air. There is also an electronic control unit, a computer that receives data from sensors around the engine. It processes this data and uses the results to operate the injectors. This section examines the diesel fuel system. The diesel fuel system contains a fuel tank to hold the fuel, a fuel supply pump to supply the system with fuel from the tank, a sedimenter to filter out water, a fuel filter to filter minute particles from the fuel, an injection pump to deliver highly pressurized fuel to the injectors, injector pipes between the injection pump and the injectors, injectors, one for each cylinder, to spray fuel into the combustion chambers, overflow and leak-off pipes to return excess fuel from the injection pump and injectors to the tank, a governor to control engine speed, and a control lever on the governor connected to the driver's accelerator. This section examines charging. The charging system provides electrical energy for all of the electrical components on the vehicle. The main parts of the charging system include the battery, the alternator, the voltage regulator, which is usually integral to the alternator, a charge warning or indicator light, and wiring that completes the circuits. The battery provides the electrical energy for starting. Then, once the engine is running, the alternator supplies all electrical components of the vehicle. It also charges the battery to replace the energy used to start the engine. The voltage regulator prevents overcharging. This section examines starting. The starting system consists of the battery, cables, starter motor, flywheel ring gear, and the ignition switch. During starting, two actions occur. The pinion of the starter motor engages with the flywheel ring gear, and the starter motor then operates to crank the engine. The starter motor is an electric motor mounted on the engine block and operated from the battery. It's designed to have high turning effort at low speeds. The starter cables are the thickest on the vehicle, as a high current must be delivered to the starter motor to turn the crankshaft from rest and keep it turning until the engine fires and runs on its own. This section examines ignition. A basic ignition system consists of the battery, low tension cables, the ignition coil, distributor, coil high tension cable, spark plug cables, and spark plugs. The ignition system provides high-intensity sparks at the spark plugs to ignite the fuel charges in the combustion chambers. The sparks must be supplied at the right time, and they must have sufficient energy over a range of conditions to ignite the charges. The energy comes from the battery and alternator, and the voltage is increased by the ignition coil. The system has two circuits. The primary or low tension circuit initiates the spark. The secondary or high tension circuit produces the high voltage and distributes it to the spark plugs. There are three general types of ignition systems. Breaker ignition uses contact breaker points in the distributor to initiate the spark. Electronic ignition doesn't need contact points. When a signal is received, triggering occurs through transistors in an ignition module. Direct ignition has no distributor and uses coils to supply high voltage direct to the spark plugs. This section examines lighting. Lighting systems improve visibility at night and make a vehicle visible to other road users. A lighting switch operates tail lights and park lights and headlights to allow the driver to see ahead. A dip switch allows the driver to change the beams from high to low or vice versa as required. Stop lights operate when the brake pedal is depressed. Turn signals alert other drivers of a change in direction and are mounted so they can be seen from the front, rear and sides of the automobile. An emergency flasher system operates both front and rear turn signals at the same time. Other circuits operate courtesy or convenience lights, reversing lights and fault indicators. This section examines the cooling system. Combustion of the air-fuel mixture in the cylinders generates heat which produces high pressure to force the piston down in the power stroke. Not all of this heat can be converted into useful work on the piston, and it must be removed to prevent seizure of moving parts. This is the role of the cooling system. Most engines are liquid-cooled. A liquid-cooled system uses coolant, a fluid that contains special chemicals mixed with water. Coolant flows through passages in the engine and through a radiator. The radiator accepts hot coolant from the engine and lowers its temperature. Air flowing around and through the radiator takes heat from the coolant. The lower temperature coolant is returned to the engine through a pump. Air cooling is common on smaller internal combustion engines. Some engines use cooling fins. Their design makes the exposed surface area as large as possible, which allows more heat energy to radiate away and be carried off in convection currents in the air. Some engines also use a fan to direct air over the fins. This section examines the lubrication system. All moving parts in an engine require lubrication. That is, the application of oil to moving parts to reduce friction between them. A lubrication system distributes oil through the engine. A typical lubrication system consists of an oil sump, an oil pump, and oil galleries. The oil is stored in the sump, bolted to the bottom of the engine block. Oil is drawn from the sump by an oil pump. Oil galleries are small passages in the cylinder block that direct oil to the moving parts. Oil that has been pumped to the crankshaft main bearings travels through oil ways to the connecting rods. Oil may also be splashed from the connecting rods onto the cylinder walls. A filter is usually provided to remove particles of dirt from the oil, and the circulation of the oil assists with the cooling of the internal parts.